Hey guys, welcome to lesson 3.4. We're going to talk about linear inequalities today. And so we're going to graph this inequality. Notice that it's in point slope form. So I'm going to grab a point, so 3, -4 from those two places. So 3, 1, 2, 3, 4, right there. And then remember, this is our slope. So I can't go down, so I'm going to go up 1, 2, 3, 4, 5, and over 2. So your goal is that you want it to go downhill, which it is. Okay, so it is, let's erase this here. This is just greater than, so it's going to be a dashed line. And so the best thing to do is just to grab that, let's see, sorry, just to grab a point. So the easiest point to grab is 0, 0. So if I grab 0, 0 and put it in for x and y here, I get 4 is greater than -5 halves times -3. And so if this is true, then I'm going to shade where 0, 0 is. If it's false, I'm going to shade the other side. So I want you to look at it as you only have two sections, 1, 2. So if it's true, that means that 0, 0 is part of that solution. So I'm going to shade on this side. If it's false, that means that 0, 0 is not a part of that solution. So I'm going to do it on the other. Okay, so I did the math, and over here, this ends up being about, I just did it as a decimal to kind of help my brain think, 7.5. So it's saying 4 is greater than 7.5. So that is definitely not true. So then I'm going to grade, or I'm going to shade on the other side. So your answer should look like that. Okay, so let's talk about compound inequalities. So again, just think about that and means intersection. It's the same thing as an intersection, and or means union. So we're gonna just kind of touch back on those concepts here. So this is an or. So it's just gonna be like everything. It's gonna be that union. So go ahead and let's just start here on this one. So just graph that. Actually, I'll go through this one because it's in standard form. So remember, in standard form, we're going to use the intercept. So I'm going to say 5x is greater than or equal to 15. So x, and I don't really care about the, I'm just getting this number here. So I'll say x equals 3. And in this case, 3y equals 15, so y equals 5. And so that's going to get us those points that we need. Now I'm interested in this. So again, just like this one up here where we used a test point, I'm going to use the same test point here. So I'm going to use 0, 0. And one more thing, it's greater than or equal to, so I'm going to do a solid line. Okay, now, so 0, 0. So here we go. What's nice about standard form is that when you plug in 0 here and 0 here, it just becomes 0 is greater than or equal to 15. So that, again, is false. So I'm going to just kind of lightly shade here. And then, so why don't you do this one over here and see what you get. Okay, so you should have gotten 3 for your x-intercept and -2 for your y-intercept, and it was a dotted line, so I showed all that. Now I'm going to use the same test point. So 0 is greater than 6. Again, that's not true, so I'm going to shade away from it. But I don't. So my answer, because it's an or, is going to be all of this. So I shaded it in better for you there. Okay, so let's go to an and. So I have that y is in between 0 and x. So I want to look at it like this because this hurts my head. So one thing I'm going to grab is right there. Y is less than x. And then also y is greater than or equal to 0. So look at the alligator is eating the y here. So just make sure that you're careful on your signs. Then also, so I kind of have 3 ands. I have this one, and this one. So x is less than 1. So I'm really going to be kind of graphing 3 things here. Okay, so let's go ahead and start off with this one. So let's put this in maybe a more easy terms. Y equals X, that would be a dotted line through here. Okay, and so the bad part about this one is that it goes through 0, 0, so I can't use 0, 0. So I might use like 0, 1 for my test point. So 0, 1, so this is X and this is Y. So 1 is less than 0. So that is not true. So I know that I'm going to shade down here. Okay, let's do another one. So let's do this one. Y is greater than 0. Okay, think about Y equals 0. So Y equals 0, that's going to be that horizontal line here, and it is a solid line. So it's going to look like that. Okay, Y is bigger than 0. So because it's an and, I don't really care about any of this. So I'm more interested in this here. So I'm already like focused on this section right there because it has both colors. Okay, let's do one more color. X is less than 1. So I'm going to look at this as X is equal to 1. And that's also a dotted line right here. And it's less than, so it's going to be to the left of it. So the only part that satisfies all three equations is this teeny tiny piece right here. Okay, so now, ooh, I don't like the way this ended up. Graph the inequality. Sorry, I don't know why the graph is so messed up here. Okay, so we have, this is a great OR, so this is going to be an OR problem. So I have 2x minus 3y is greater than 9, or 2x minus 3y is less than negative 9. Okay, so go ahead and I think you're able to graph one or both of them, and then we'll meet up. Okay, so please forgive my terrible graphs. I'm realizing that I cannot graph very well when I'm using my computer, so please forgive me. Okay, so I came up with these two lines here, and we shaded this earlier, so let's look at the shading here. So 0 is less than negative 9. Well, that's not true either, so this 0, 0 is not going to work for either of them, so we're shading away. Okay, because it's an OR, then this is good. If it were an and, it would be no solution. But because it's an or, it's just this yuckiness. So it's all this stuff up here and all this stuff down here. Okay, so notice that this one, because it's less than, it's going to be an and or an intersection. So see what you can do on that, and we'll meet up. I just wanted to take a moment to stop and show you what I graphed after that first one. So I'm just looking at this one. I liked that this was a nice y-intercept. I didn't like that. That was too yucky for me. So I went back on what I told you guys about the slope, and I used that negative a over b, and I figured out the slope was 5/2. So I just kind of just used what I had to my benefit. So I just started at that -3 and I went up 1, 2, 3, 4, 5 and over 2. I liked that better than using the x-intercept. And then I used my test point and it actually ended up true. So I'm going to use 0, 0 as part of my shading. Okay, now I'm going to go on to the next one. Okay, so this one, I noticed that my slopes were the same. So just like the last one, they're parallel. And I did the same thing. So I found my y-intercept and I just used the slope to graph it. And it was true as well. So it's going down, this is going up. And because it's an and, I am just worried about this in the middle as my solution. So that is it. Okay, so for this next one, go ahead and read through it. And I'm going to push pause and I'm going to just kind of go through my thought process. So I'm going to tell you, this is the first place I started, and I think that maybe you might have started there too. I don't know, maybe you're smarter than me, but I felt like I wanted to set up an equation like this. But then I wrote that down, and then I got to here, and it says write a system of inequalities that shows all possible combinations of doubles and triples that can be made. So then I looked at it from like a meat perspective and a pickle perspective because it told me that we have 28 or 24 meat patties and 48 pickles. So that's why I chose to do it this way versus this way. Okay, so now I'm going to graph each one of these. So let's do that next. Okay, so I went ahead and labeled this doubles and tripled, and I just did that for the way it was labeled. So D kind of as my X and T as my Y. You can flip-flop those as long as you stay consistent. And I ended up with this. Now, for these problems, notice we don't have like other quadrants because that's all like negative values. Also, 0 is less than 24, so I know that I'm like shading through here. So I'm going to go on to the next one. Okay, so I found my other one, and so that shows all the possible combinations of doubles and triples. So this one is going to be shaded down as well. So I am interested in this section here. And this is called linear programming, and we are going to talk about that later. But this is just kind of the basic idea of it. So just to answer the question, right, system of inequality. So this would satisfy that, and graph it. That's what your graph would look like. And we are done. We're done.